I proceed, I implore each one of us that has managed to join, to subscribe to our YouTube channel, SBA Online Academy, that's Science Bridge Africa. So you go to YouTube and then search Science Bridge Africa, SBA. So you subscribe, like, and comment so you do not miss our subsequent lessons. So today, in the interest of time, we shall look at roots of quadratic equations. Roots of quadratic equations. So I'm going to be sharing with you the PDF as we do the working. So roots of quadratic equations. So we are saying that any equation of the form ax squared plus bx. So any equation of the form ax squared plus bx is equal to 0, where a is not equal to 0 is called a quadratic equation. So any equation of that form is called a quadratic equation. And we always solve that equation using bulldozer, and the bulldozer method we always know is if you're given that equation, we always use a bulldozer method, that is x is equal to negative b plus or minus root of b squared minus 4ac divided by 2a. Is the bulldozer method that is used to solve the quadratic equations. And usually in that bulldozer method there is the square root, but in the square root we are having b squared minus 4ac, and we always call that b squared minus 4ac to be our determinant. So that b squared minus 4ac determines the nature of the answers you'll be getting for your particular quadratic equation. So it is the discriminant. It determines the nature of root. So we must be very keen with that b squared minus 4ac. So we are going to look at how we can use our equation, our bulldozer method, to solve different quadratic equations. But before maybe we go to that, we need to first of all know that quadratic equations can be solved using different methods. We cannot only use the bulldozer, but we can as well use factorization. We can as well use completing squares. And we know that if you've done some mathematics, you realize that that bulldozer method comes from the completing the square method. So the bulldozer comes from the completing square method. So if at all we say that we are having, let me try to show it. So we are having x squared, this is the square, x square plus bx plus c is equal to a 0. So now we are saying that we can solve this using bulldozer, and usually if this is we are solving for x, it will be x equaling to negative b plus or minus square root of b squared minus 4ac when divided by 2a. This is our bulldozer method that we always use. So we just happen to substitute in the values of a, b, and c. But now we are saying, how do we arrive to this? How do we arrive to this quadratic, the bulldozer method? How do we arrive to that? So we're going to know, how do we arrive to that? We arrive to that by completing square method. Completing squares. So we are going to, in our lesson today, we're going to first of all learn how to complete squares, and then we shall look at other parts of the topic. So let us try to understand the complete square method, and then we proceed. So now, how do we complete squares for any given quadratic equation? For any given quadratic equation, how do we complete squares? How do we complete squares for any quadratic equation? So you realize that if this is our quadratic equation, let me try to change the ink. Let me try to use black. So if this is our quadratic equation, ax squared plus bx plus c is equal to a 0. So The very first step that we always do in completing squares is to ensure that the coefficient of the x squared is 1. But now when you look at this equation here, the coefficient of the x squared is a. So meaning that your first step is to make that coefficient to be 1. But how do you make the coefficient to be 1 here? By dividing all through by a, by a, by a, by a throughout. So when you divide all through by a, you realize that now you come up with a nice expression like, this will be x square plus b out of a, x plus c out of a is equal to 0. So this will be equal to a 0. That will be equal to a 0. So now, if you have that now, you've managed to make the coefficient of x squared to be a 1. So now, after making the coefficient of x to be 1, you come up with a nice expression. This is the nice expression you have come up with. You've come up with a nice expression, x square plus b out of a, x plus c out of a is equal to a 0. This is a nice expression we have. So after getting that nice expression, what is our next step in completing squares? Is to look at the coefficient of now the x. Is to look at the coefficient of the x without the square. So this is the coefficient b out of a. So what do we do that coefficient of x? We always divide it by a 2. You can say divide it by a 2 or multiply it with a half. It is literally the same thing. Multiplying by a half and dividing by a 2 is the same thing. So when you multiply by by a half, or when you divide by 2 here, just the coefficient, you come up with b out of 2a. You come up with b out of 2a. So when you multiply the coefficient of this, of the x without the square, this one alone, you come up with this one. When you divide it, you come up with the will be b out of 2a. So now this b out of 2a you've got, the b out of 2a you've got, we are now going to square it and add it to either sides of the equation, of the equal signs. So you have got b out of 2a, but now after getting that b out of 2a, we now are ought to square it and add it on either sides of the equal sign of the equation. So we shall square it and add it here and also add it to the other side. So how do we do that? So we say this will be x square plus b out of a. So multiplying by a half here doesn't mean that we change this part. We only use it. You just pick it and then use it, but we do not change the original outlook of this part. So this will be b out of a, x plus, so we are adding this but squared, we are adding it on either side. So b out of 2a, we are adding it on either side, so it is a square, and then plus c out of a, so we have added it on this side, so let us also add it on this side, so it will be 0 plus this, so meaning that this will be b out of 2a squared. So we've added it on either sides. We've squared it and added it on either sides. So we've added it on either side. So we come up with that nice expression. Now, after adding it on either side, let us now try to shift this part. Let us try to like collect like terms. Remember, this is a constant. It's like any number. It can be 3, it can be 4. Any number, it's a constant. So we try to shift it by taking it to the other side of the equal sign. So by taking it to the other side of the equal sign. So now you realize that now if you take it the other side of the equal sign, you come up with this will be x square. This will be a square plus b ax plus this will be b into 2a. This will be 2 and then equal to. So this will be, if this square enters the bracket, this will be b squared minus, if it comes down here, it will be 4 a squared, and then we are saying that we are subtracting this the other side, so it will be minus c out of a. So you have that nice expression now. So now you realize that you've got this part of the equal sign that's having a square. So we happen to generate a bracket that is combining this square and that square. So you pick this x without the square, so you generate a single bracket that is combining that two. So this will be x without the square, and then plus this b out of 2a without the square, but we combine them and then give them a single square. But you realize that if you happen to expand this bracket, you come up with all of this one with also this one included. Yet it wasn't in our plans when we are making this single bracket. But if you try to expand it, you come up with all of that. So this will be equal to, so make the LCM here. LCM here will be 4a squared. So LCM 4a squared, divide it here, you come up with b squared, and then divide it here, you come up with the 4ac. So now after getting our 4ac, you realize that now we need to eliminate the square here. So how do we eliminate the square? By squaring either sides. Squaring either sides, you come up with the square of x plus b out of 2a, then the squared equaling to, when you square this side, you come up with b squared minus 4ac divided by 4a squared. So you realize that this square is cancelling out with this square. So you come up with your x plus b out of 2a equaling to, this will be a root of b squared minus 4ac. Let me try to get some space here. So this is a square root of, this will be b squared minus 4ac divided by 4a squared. So you come up with that nice expression. So now remember, our aim is to make x the subject of this formula. So how do we make x the subject of that formula? By taking b out of a, this other side. So this will be x equaling to, we are taking that b out of a this side. So this will be negative b out of 2a, and then this will be equal to, remember this was whenever you get a square root of any number, it is either positive or negative, and then this will be root of b squared minus 4ac. But remember, this root can be put on the numerator, and then it can also be put on the denominator. So it is the same thing. So this will be 4a squared. So after getting the 4a squared, let us now simplify to come up with our Buluza method. Our Buluza method will be now x equaling to negative b out of 2a plus or minus, up here you're having root of b squared minus 4ac, and then divided by root of 4a squared, it will be a 2, and then this will be a. So root again, that the root will come to 4 to get a 2, and then to come to a squared to cancel that square, and then you come up with this. Let us continue to let us continue simplify this. So this will be x equaling to, if you get that, this will be equal to, let me try to write it well. So this will be equal to x will be equal to, so when you try to get the LCM of the whole of this, it is 2a. And then if you divide it here, this will be negative b plus or minus, this will be root of b squared minus 4ac. So this comes to be our bulldozer method that we need to use always when calculating these quadratic equations, when getting the value of x. So you come up with that nice quadratic equation. But remember, we said that in quadratic equations, always this b squared, this b squared minus 4ac is the discriminant, or the determinant. It always determines the nature of the answers we get, and always those answers are the roots of that quadratic equation. So now, after knowing the quadratic, how to derive that quadratic equations from completing squares, let us also now look at how can we now use this this method to know the nature of the nature of roots. Let us know how to know the nature of roots. So simply, so let us look at briefly nature of roots for any quadratic equation, because we can have roots like they can be real, distinct, but we can as well have roots that are not real, they're just imaginary, and then we can also have those that are repeated. So we are going to be looking at that. Let us go back to our PDF. Let's go back to our PDF and find out. So we are done with the completing square method. So let us go to our PDF and look at the nature of roots. So now you realize that if if let me just write it anyway, save time. So you realize that if this is point number one, if that discriminant b squared minus 4ac, if that discriminant b squared minus 4ac is positive, if it is positive, if it is positive, implying that if at all you substituting the values of b, the values of a and c in there, you get a positive answer, meaning that that b squared minus 4ac is greater than a 0. What does that imply? What does that imply? So that implies that that quadratic equation that we are solving using the bulldozer has got real and distinct distinct roots. For example, if you try to solve any quadratic equation and you get answers like maybe 1 and 2, maybe -2, like you get two answers that are real and different. So that's when we call them real and distinct roots. So that comes about when your b squared minus 4ac is greater than 0, or when it is positive, or as you get roots that are real and distinct. Then scenario number 2. So if at all you get if your b squared minus 4ac is negative, implying that the b squared minus 4ac is uh, less than 0. So always know that numbers less than 0 are negative. So if it is less than a 0, we normally get no real roots. If it is greater than less than a 0, we normally get no real roots. So we normally get no real roots. No real roots. No real roots. We can call them imaginary roots. If they are not real, they are imaginary. So you can call them that. And then scenario number 2, number 3, if your b squared, the discriminant for ac, is equal to a 0, now when you substitute in, you come up with your answer in the square root as a 0, meaning that you shall get repeated root c. So repeated roots, that's a scenario where when you solve the quadratic equation, anyway, when you put it in the calculator, you come up with only one answer and it is repeated. You get maybe 2. So that's when your b squared minus 4ac is a 0. So you come up with that. So hope you are together with the nature of roots. So we just need to note these keynotes. These keynotes, the 3 points. If the discriminant b squared minus 4ac is greater than a 0, you get real and distinct roots. When it is less than a 0, you get imaginary roots or no real roots. If it is equal to a 0, you get repeated roots. This is what we mean. That if at all maybe this is your quadratic equation, you are solving this part here, and then you happen to get an answer. When you substitute for b, you substitute for a and c, you come up with an answer that is positive, that is greater than 1, you always get real and repeated roots. But there are scenarios where when you substitute for b, you substitute for a and c, you come up with a negative answer, and you always know that we do not have, when you press your calculator, we do not have answers negative root of negative integers, so we always get math error. So for us to mitigate that negative that math error, we always apply some complexes there, so we get imaginary roots. And then when you look at when you substitute for your b, your a and c, and you're getting 0, meaning that you're getting root of 0, implies that you shall have repeated roots, implying that if root of 0 is 0, so the whole of this part will be cancelling out, and we will be only left with negative b out of 2a, meaning that you only get one answer, and that's why we are calling that that root as repeated d. Are we together there? So we are done. Let us now maybe look at the questions, how we can use this concept to know the nature of roots. So we are done with that. We are done with that. We are done with that. So we are going to look at the nature of roots. using this concept we've learned today. So let us look at the nature of roots. Nature of roots. Nature of roots. So let me get you some questions so we see if we can apply this this concept. If you can apply this concept. So now this is let us use this as our examples. Example, yeah, this is example 2, but let's start with this. So in this example, we are tasked to determine the nature of roots of the following equations. We are given equations A, B, and C and D. So we need to check the nature of roots in these equations. And we are starting with equation 1. You're starting with equation 1. So you realize that if this is your equation 1, you try to compare it with the original, with the general equation of a quadratic equation. The general format of a quadratic equation is A x squared plus B x plus C. So you try to compare it. Why do you compare it? We need to find out the values of A. You find out the value of B and the value of C. So if you try to compare, you realize that the value of A here is 1, the value of B is -6, and the value of C is 9. After getting the values of A, B, and C, you now try to substitute in your discriminant, B squared minus 4AC. So now when you substitute in the value of B, you substitute in the value of A, you substitute in the value of C. So you come up with -6 squared minus 4 times 1 times 9. So you come up with 36 minus 36, and that's a 0. So this being a 0, it implies that from our concept we learned up there, it implies that these roots are repeated. Just nice concept. Yes, when you get a 0, if your discriminant gives you a 0, meaning that the roots are repeated. And then 2, if this is our equation 2, if you try to compare this, you also come up with the values of A, B, and C, and then you try to put it in your discriminant. If you put it in the discriminant, you come up with 4 minus 4, which is a 0, meaning that also those roots are repeated. I want us to find some equation that is having some imaginary and then real and distinct roots. So this is equation 2. Equation number 3. So equation number 3 still before the same concept of finding the value of A, B, and C from the equation by comparing with the general expression of the quadratic equation. So you come up with your, when you substitute in here, you come up with your 36 minus 40, and that's negative. So I say that whenever you get negative, an answer that is less than 0, the roots are imaginary, they are not real. That's why we are saying that no real roots. So that's why we are getting no real roots, because of this negative we've got after substituting in our discriminant. So now after that, let's also check this last question here. Last question is 4x squared minus 12x minus 9 is equal to a 0. So you realize that if you try to compare this equation with the general equation of the quadratic, so you realize that you come up with the value of A, the value of B, the value of C. And then after you get the value of A, B, and C, you try to substitute in there in your discriminant. If you put in your discriminant, you come up with your answer as 160. So 160 is a positive integer that is greater than 0. So meaning that if it is greater than 0, this implies that our discriminant is given, our roots are real and distinct. So this is what I was talking about. This is what I was talking about. So hope everyone is safe with that first working. So just looking at the nature of roots, substituting in the discriminant, which discriminant you must recall the discriminant is B squared minus 4AC. Yes. So if it is equal to a 0, repeated roots. If it is greater than 0, real and distinct roots. If it is less than 0, imaginary roots or no real roots. That's the concept. Just simple like that. So now let us also look at let us get some other question here. Let us try to get some other questions here. So we are done with that. Let's get another question here. So let us look at maximum and minimum values of quadratic equations. Maximum and minimum values of quadratic equations. Maximum and minimum values of quadratic equations. So this is our next part, maximum and minimum values of quadratic equations. So it's our next part. Maximum and minimum value of quadratic equations. Maximum and minimum value of quadratic equations. So for you to be in position to know the maximum and minimum value of any quadratic equation, you must be well versed with the completing square method. If you do not know completing square method, you cannot find the maximum and minimum value of the quadratic equations. Let us try to use our completing squares to know the maximum and minimum value of quadratic equations. So for us to be knowing the minimum and maximum value of these quadratic equations, our first know is we recall the completing square method. So we are given this, we are given the question. Find the greatest or least values of the following functions. So we're given these quadratic equations, they are arranged in different formats, but still because the highest power there is a square, so we shall consider that as quadratic equations. And then we are told to find greatest or least. We do not know the answers we shall get. We shall either get greatest or least. So how do we now get the greatest or least values? Using completing square method. So it is very simple. It is very simple. So you realize that you're given our part A, you're given x squared minus x plus 5. So you realize that for me to be in position to find the least or greatest value, I'll complete squares. And in our first minutes, we looked at completing square method. So we say that for you to be in position to complete square method, you must ensure that the coefficient, if this is your equation, let me try to write here. If this is your equation, x squared minus 2x plus 5, you must first of all ensure that the coefficient of the x with a square is a 1, and here it is unfortunately that the square, I think the coefficient there is a 1. So meaning that we shall proceed to our next step. So next step, after making 1 here, the next step is to multiply a half, or maybe you can call it a dividing by 2 here. So when you multiply a half here on the coefficient of x without a square, the answer you get, you square it and add it on either sides of the equal sign. So now the coefficient is negative. So when you divide by 2, you get negative 1. That negative 1 you get, you square it and add it on either side. So meaning that we shall now say this will be x squared minus 2. So this remains are the same, but now when you divide by 2 here, you get negative 1. So that negative 1 you get, you add it, you square it and add it on either sides of the equal sign. So we add it there. And now because of this equation has no equal signs, we shall always, instead of adding it the other side, we shall instead subtract it here, because this equation has no what? Has no the equation uh, has no equal signs. Equation has no equal signs. So this stands to be our next step. So multiplying a half here, and then the answer you get, you square it and add it on either sides of the equal sign. So after doing that, you realize that you've got this part of the question. Which part of the question has this square and this square? So you try to generate a single bracket that has x without the square, and then this negative 1 initially had a square, but we shall first of all discard the square, and then we generate a single bracket that has got a single square. Meaning that if you try to expand this again, you come up with all of this one with the square included. So this will be 5 plus this will be 5, and then if you try to gather this will be negative 1 square, that's a 1, so this will be minus 1, and then you come up with your x minus 1, this is a square, and then this will be plus f4. So you come up with that nice what? With that nice expression. But now our question remains: is this are we getting the greatest or you're getting the least value? So we are getting the least value. Why do you get the least value? Because of this plus. Whenever you get a plus in here, that's a least value. But if at all, okay, let us arrange this. So if this is, we let this should be y, will be x minus 1 squared plus 4. So the least value here, we are saying the least value is a 4. The least value of y is a 4, and it occurs when x minus 1 squared is equal to a 0. That's how easy we can do that. If you have a plus here, you always talk about the least. If you had a negative here, we would talk about greatest. But now we have a plus, so it is the least value of y, and it occurs when this x squared is equal to a 0. So when you equate this 0, so you come up with your y as, as a 4. So let us get another question that will give us maybe the greatest. This our next question is giving us the greatest value. So now look at part B, and I think here we shall be having the see how we can now conclude by saying the greatest value. So now for this part, you realize that you're given 5 minus 4x minus x squared. So for this part here, you don't necessarily need it to arrange this in a format of a quadratic equation. So what you need, you just need a portion that will give you that that impression of a quadratic equation. So we can easily say that this is equal to, this will be 5. So you see that the negative and negative here, they are common, so you factorize it out. So you come up with 4. Sorry, this can be x square and then plus 4x. So you factorize out a negative there. So now after factorizing a negative there, you realize that you've come up with a bracket that is having a quadratic impression. So now you try to complete squares for that part. So complete squares, you realize that you start by making 1 here, but it is already 1. And then 2, you divide by 2 on the coefficient of the x without a square. So when you divide by 2 here, you come up with 8/2. So this will be equal to 5 minus into bracket. We are dealing with the bracket. So this will be minus into bracket x squared and then plus 4x. So plus 4x, you realize that you normally need to divide here by 2, and then the answer you get, to square it and add it on either side. So we shall add it here, we shall square that 2 we've got and add it here, and then we shall subtract it the other side of the equal sign. But still we do not have equal signs here, we shall be like subtracting it again. So we shall be like subtracting it. So it will be a 2 minus a 2 squared. A 2 squared. This will be a 2 squared. So now after doing that, you realize you're coming up with a 5, and then inside the bracket, you try to generate a single bracket that will combine this x square and this 2. So this will be x in the bracket, and then it is a positive, so it will be a plus 2, and then you give them a single bracket that will combine them both. So minus, this will be minus, what is 2 squared? It is a 4. It is a 4. And then that's a 4. And then remember that all of this one is this bracket, this negative here is affecting the whole of this part here. So meaning that this will be a positive. So this negative here is affecting the whole of this part. So this negative will affect this bracket and also affect this bracket. So you come up with 5 plus 4, and that's 9. That's 9, and then this bracket will be into x plus a 2, and then this will be a square. So you realize that now for this case you've got a negative here. For our first part we got a positive here. So here we are getting a negative because that negative usually indicates that we are getting greatest value. So the greatest value of y is 9. If at all you let this one to be a y, so this will be the greatest value will be 9 when x plus 2 squared is equal to a 0. So meaning that the main points to note here, if you get this bracket positive, if you get this bracket in very positive, it implies least value. If you get that bracket negative, it implies greatest value. Just as simple as that. So no logic there. There is no logic there. So you just, if you get a positive bracket, that's least. If you get negative bracket by after completing squares, that's a greatest value. So you conclude by saying it is greatest value over least value when that square bracket is equal to a 0. So that's how we can easily get our maximum and then minimum value. So you can get some more questions and then try out, but for that case, we can stop at that. We can stop at that, and then we look at something new. You're going to look at something new. You're going to look at something new. You're going to look at something new. So you're looking at something new. You're looking at something new. So you're looking at something new. uh, Hope you are together with the quadratic equations and then solving getting the nature of roots and then finding the maximum and minimum value. So after we've known all that, we now need to look at what we call the sum and product of roots of quadratic equations. Sum and product of roots of quadratic equations. So we need to look at that also. Sum and product of roots of quadratic equation. This is our next plot. That's our next plot. So now, how do we know the sum product of roots of quadratic equation? So you realize that I told you that the general equation of any quadratic expression is the general expression is x squared plus bx plus c is equal to 2s0. And usually we try to make the coefficient of x squared as 1. That's why we divided by a. So you come up with x squared plus bx over a plus out of a is equal to a 0. So you come up with that. So now, after coming up with that, you realize that if we consider alpha and beta to be the roots of the equation, if you consider your alpha and beta to be the roots of equation, if alpha and beta are the roots of the equation, if alpha and beta are the roots of the equation, if alpha and beta are the roots of the equation, if alpha and beta are the roots of the equation. So you realize that roots, it means that roots literally means that the value of x. So if you get your maybe your x, if you solve any quadratic equation and you come up with your value of x as maybe 2 and then the other as maybe 3, so you realize that these two are the 2 is a root of that equation. That's why we are saying that this x is equal to alpha and then this other x will be equal to a beta. So alpha and beta are roots of the equation. So if alpha and beta are the answers we get after solving the quadratic equation, so you realize that if you try to equate, or maybe you try to take alpha this other side, it will be x minus alpha, and then x minus alpha, it gives us s0, and then also this one, x minus beta gives us s0. So x minus beta gives us a 0, and then x minus alpha gives us a 0. So if you try to multiply these two brackets, if you try to multiply this, if you try, because this is equal to a 0, even this one is equal to a 0, meaning that if you multiply these two brackets, you also come up with a 0. So this is what we got. This is what we got. So you come up with a 0. So now after equating them, after multiplying and equating them to a 0, you try to expand and then you come up with this nice expression. So after getting this nice expression, you now try to relate it. You try to relate it with the general expression of a quadratic equation. So you're trying to relate it with the general expression of a quadratic equation. So now, if you try to relate this and this, you realize that your alpha plus beta will be equal to b out of a. So your alpha here is negative alpha plus beta, giving us b out of a, and then this alpha beta will be c out of a. So hope you can see that. Hope you can see that. So you realize that if this is if you try to compare, if you try to compare if you try to compare this one, this is negative, this is alpha plus beta. So if you try to compare it with this this equation here of the general expression of a quadratic equation, so you come up with you realize that negative alpha plus beta will be equal to b out of a, and then alpha plus beta will be c out of a. So you are trying to compare with that. So you come up with these expressions. They are nice expressions here. So nice expressions we come up with negative alpha plus beta is equal to c, sorry, b out of a. And then if you try to make it negative, you eliminate a negative, you come up with alpha plus beta equaling negative b out of a. So you come up with that. And then similarly, alpha plus beta is equal to c out of a. So you have that. And then so for any quadratic equation, the sum of roots is alpha plus beta, because we say that if alpha and the beta, if alpha and beta are the roots of the equation, so guys, that if you want to get sum of roots it will be alpha plus beta. And then if you want to get the product of roots, it will be alpha times beta. So meaning that alpha plus beta is negative b out of a, and then alpha times beta is equal to c out of a. So you come up with those nice expressions. So that's the preamble for our sum and product of roots, our subtopic there. And then you realize that if at all we are going to deal with questions that are inquiring us to use these are just expressions that are found in logo books. The expressions found in logo books. So you can as well have them in your head. You can always check the logo book to give you these nice expressions. We are going to be using them. So the first expression is a alpha squared plus beta squared equaling to alpha plus beta squared minus 2 alpha beta. That's one expression that we are going to use in our calculations. And then alpha cubed plus beta cubed is equal to alpha plus beta and brackets cubed minus 3 alpha beta into alpha plus beta. That's another equation that we are going to use. And then we also have this one here. Alpha, so this was a mistake. This was a typo. Sorry, do not consider it. This was a typo. Do not consider that. So the actual check them out. Let me check them out. So you have this other one. So if alpha minus beta is equal to root of alpha minus beta squared, hope you can all know that. If I want alpha minus beta, I will get the square root of the alpha minus beta, that is squared. This I will definitely come up with this one that is not squared. That's the thing. So after doing that, you try to expand this one inside here. You expand, this will be alpha squared minus 2 alpha beta plus beta squared. So you come up with this expression, alpha squared plus beta squared minus 2 alpha beta. But you remember, you already know this. You already know this from this. You already know this from the expressions we had at first there. So we say that alpha squared plus beta squared is equal to alpha plus beta in bracket squared plus sorry, this is minus so minus 2 alpha beta. So you have that. So you have different expansions here that we are going to be using in our calculations. And the most important are these ones. The following are important formulas that you can use under roots and quadratic equations. These are the very important roots that we are going to be using. So, and then after knowing all those expansions, so we are going to try out questions here. We're going to try out questions here. I think we shall do around 2 examples. Shall do around 2 examples, and then we shall call it a lesson. So we shall do around 2 examples and then we shall call it a lesson. So example 1, so I'm doing example 1. So I'm doing example 1. So example 1, if alpha and beta are roots of the equation x squared plus 8x plus 1 is equal to 0, find the value of alpha beta, alpha plus beta, alpha squared beta plus alpha beta squared, and then alpha squared plus beta squared. So we need to find out the uh, the values of this, if this is the equation, and then alpha and beta are the roots of the equation. So for us to be in position to do that, we must first of all compare this given equation with the general equation of the quadratic expression. So you realize that if you compare it, you come up with your a as 1, your b as 8, and then c as 1. And then if you after doing that, you should just remember that a, you should just need to remember that alpha plus beta is equal to negative b out of a, and then alpha times beta is equal to c out of a. So those are the key notes that we need to remember. So now after getting the values of a, b, and c, you just substitute in here. You substitute the value of b here, substitute the value of a here. So you come up with your value. So if you want alpha plus beta for part B, put B here as 8 and then 1 for A, and then you come up with your answer as negative 8. If you want alpha beta, you put your C here as 1 and then your A as 1, you come up with 1. And then if you want alpha squared, beta plus alpha beta squared, here you just do some mathematics, some simple mathematics. You do some factorization actually. So you do some factorization. So you realize that alpha beta is common here. So you factorize it out. Alpha beta is common here. So you factorize it out. If you factorize it out, you come up with alpha beta into alpha plus beta. So alpha plus beta, you know alpha beta, you know alpha plus beta. So you just need to substitute. You already got alpha beta, you put it 1 there. You also have alpha plus beta negative 8, so you put it here. So you come up with your answer. As simple as that. So I've already told the students that mathematics is all about concepts and algebra. If at all you're good with other concept, you've got a concept and then you know your algebra. By algebra, I mean factorization, subtraction, multiplication, division, use of brackets, body mass, algebra. So you're good with the mathematics. Get the concept, practice your algebra. So mathematics is not all about the numbers you calculated. It's all about the concept and algebra. So practice just makes you perfect by minimizing the mistakes you always do. So now, let us proceed. Let us finalize with our part D. So our part D, we are told to find a alpha squared plus beta squared. And then alpha squared plus beta squared, you already know the expansion for that. You already know the expansion for that. So you just need to bring it out. So it will be alpha plus beta squared minus 2 alpha beta, and then you try to substitute for your alpha beta. You've already got it up there, and then your alpha beta, you have it there. So you substitute your negative 8 and then your 1, you come up with your alpha squared plus beta squared as 62. That was example 1. That was example 1. I think we need to do some more 3 or 2 examples. So 3 or 2 examples, and then you realize that for our part example 2, we still given that quadratic equation in there, and then they are given they have told us that alpha and beta are the roots of that quadratic equation. So find the values of alpha plus beta and then alpha beta. Find the values of alpha plus beta and then alpha beta, and then after you find the values of alpha squared plus beta squared, and then alpha minus beta squared, and then this other part. So we still follow the same concept. We first of all compare this given quadratic equation with the general expression of the quadratic equation. So you realize that your a, if you compare, your a will be 1, your b will be negative 1, and then your c will be negative 1. After getting the values of a, b, and c, you now try to substitute. Remember, you should always recall that for any quadratic equation given alpha and beta as roots of the equation, alpha plus beta will be equal to negative b out of a, and then alpha beta is equal to c out of a. So now after doing that, you substitute for your values of a and b, so you come up with alpha plus beta. The moment you get alpha plus beta, you're already done with the question. You just need to do some substitutions and then attempt these other questions. But for this case, getting alpha plus beta and alpha beta is the foundation of the question. So after getting our alpha plus beta and then alpha beta, we try to solve these other questions. So alpha, let me try to zoom maybe. So alpha, let me try to zoom. So you have that part A, alpha squared plus beta squared, and then you recall the expression that we had up there. It was alpha plus beta squared in brackets minus 2 alpha beta. So after getting that, you try to substitute in the values of alpha plus beta, then alpha beta you already have here. So you get your alpha squared plus beta squared as 7. And then you still do the same thing for this other part, alpha minus beta, you try to expand it, and then you come up with this nice expression. So after getting that nice expression, do other questions. You can use that idea to do other questions. Maybe let me try to get some advanced example. Let me try to get some advanced example here that is having. Let me try to get some advanced example, and I think it will be our very last example for this session. To be the very last example for that session. So I will leave you to try out different questions, but let me try to get you some advanced examples. This is a nice one. Let me try to zoom it. So this is our very last example that we're going to try out. So we have this example. So it is if let us try to read it together. So if alpha squared and beta squared are the roots of the equation x squared minus 21x plus 4 is equal to a 0, and alpha and beta are both positive integers, find alpha beta and alpha plus beta. Then you realize that we've got alpha squared and beta squared as the roots of the equation. Yet initially we are having alpha and beta as our roots of the equation. But for this case, we are having alpha squared plus beta squared as the roots. So we will change the roots from alpha beta to alpha squared and beta squared. So we still follow the same work. So you know that for you to get the sum of you know that from the general equation of a quadratic expression that negative b out of a is the sum of the roots, and then c out of a is the product of roots. So you realize that if I'm to get the values of alpha beta and then alpha plus beta, I'll first of all know that if I add my roots alpha squared plus beta squared, I come up with the negative b out of a, as we have done before. And then I also know that if I multiply these roots, I will be getting, so let me try to write it here. So this will be, I'm saying alpha squared plus beta squared is the sum of roots, and it is equal to negative b out of a. And then alpha squared beta squared is equal to c out of a. So you realize that these are the new sum and product of roots. So what is your b from the question? Your b is negative 21. What is our a? Our a is 1, and then our c is 4. So you try to substitute in here. So when you substitute in here, you come up with your 21 as the sum of roots, and then you come up with your 4 as the product of roots. So after doing that, you realize that the alpha squared plus beta squared is 21. But you remember the expression for alpha squared and beta squared was alpha plus beta squared minus 2 alpha beta. You remember this from our first working. And then you try to substitute. In. So alpha, if you try to make it the subject of the formula, because this will be alpha plus beta in bracket. Then if you try to substitute in the value, this will be 21. You already know that. and then this is because from this point here, let me try to elaborate this. So if this is alpha, let me try to elaborate it here. Let me try to elaborate it here. So it is alpha squared, beta squared equaling to a 4. So if you want to get the value of alpha beta, it will be alpha beta, and then if you square it, you pull that using indices, you pull that square out, this will be equal to a4, and then if you try to make this the subject of the formula, you put the square root of 4, and you come up with your alpha beta as equal to 8. That's why after expanding this, you have alpha there, so you put a 2 here, and then you also have this one as 21. So meaning that you're only left with alpha plus beta as your unknown there. So you get it, and it is 5. So alpha beta is 2, and then alpha plus beta is 5. And that was the gist of the question. That was the gist of our question. So I think at this rate, we've exhausted the roots, the sum and product uh, of roots of quadratic equation. Maybe we are left with only this other part, and this will mark the end of our lesson if at all we capture it. I think let me try to. So let us look at how we can generate uh, quadratic equations given the roots. Let us see how we can generate quadratic equations. This is our last part. So generating quadratic equations given roots. Generating quadratic equation given roots. So the question here is the question here that we are going to be aiding. It is write down the equation whose roots are. So we are given roots, and then we need to find the equations whose roots are these. So how do we write the equation of roots? So we are going to try out only two examples are enough. So write down the equation whose roots are Roman part A. We are having roots 4, 3, and 4. So how do we do that? So you should always recall that for any quadratic equation is in the form of x squared minus sum of roots x plus product of roots equals to 0. This is the general expression for any quadratic equation. X squared minus sum of roots x plus product of roots is equal to 0. So your only work here is to know this expression, and then you try to substitute in the value of the sum of roots and then also the product of roots. So if these are your roots, how do you get the sum? By adding these roots. So you add, you get 3 plus 4, you get 7. And then the product, you multiply 3 times 4, you get 12. So you substitute in, and then you come up with your nice quadratic equation as x squared minus 7x plus 12 is equal to 0. So for any quadratic equation is in the form of x squared minus sum of roots plus product of roots is equal to 0. So you just need to, if these are the roots given, you just need to get the sum of these roots and then the product of these roots, and then you substitute in your general expression. Same applies to these other roots. Same applies to these other roots. Same applies to these other roots. So I have always told students in mathematics, you only need the concept and then algebra. It is not all about the questions you've attempted, but as long as you have the concept, algebra, you can attempt any question that comes across. So I think this marks the end of our lesson. Thanks so much for joining. Wish you a nice day.